have a question. Do LLMs actually make decisions? It seems there's more to it than just predicting the next word. Most people say no, it's just a fancy autocomplete, but that's like saying a Ferrari is just a bunch of explosions. Technically true, but it doesn't explain how the car just got you to Starbucks. Today, you're going to learn 3 things. 1, why the "it just predicts words" argument is misunderstanding something critical. 2, how the math in these models relates tokens to each other to mimic logic. And 3, how researchers are moving past simple prediction into something called latent space computing. Basically the next generation of AI. You don't have to be technical to understand this, you just have to be a human curious about AI, and at the end of the video you'll be honorary AI researchers once you understand it. When people make statements about LLM's reasoning or not, they're usually mixing up 3 very different things: logical reasoning, behavioral reasoning, and internal reasoning. The secret is, LLMs can only convincingly do one of these. First, let's talk about internal reasoning. This is what most of us mean when we say thinking. It's having goals, beliefs, and inner dialogue in our head. When you're deciding to grab a snack because you're hungry, that's internal. LLMs have 0 internal reasoning. Inside the model, there are no feelings or desires, but only numerical transformations. No one's home. It's just a math responding to a signal. Then there's logical reasoning. If A equals B and B equals C, then A equals C. People think AI is a logic god, but it's actually kind of a fraud here. It can perform logic if the pattern matches something it has seen a billion times before in its training data. If you give it a logic puzzle that breaks the usual patterns though, it fails miserably. But here's where it gets interesting. What LLMs are actually world class at is behavioral reasoning. This is the ability to produce a sequence of steps that looks exactly like how a smart human solves a problem. If you ask it to plan a trip to Tokyo, the AI isn't deciding on a hotel because it wants to go there. It's calculating the behavioral pattern of a travel agent. It has a perfect map of how your brain sounds when it's being logical. How? We'll get to that in a second. But think of it like a task at your job that requires 5 steps. To get the result, you conduct reasoning at every step. The LLM does the same thing, but it just does it through math. I don't see a problem with that. So this is where that "it's just predicting the next word" argument really falls apart. People use that phrase to make it sound like the AI is just a fancy autocomplete, but the reality is, to predict the next word of a complex plan correctly, the AI has to simulate the logic required to get there. If I ask you to finish the sentence, the best way to get to the airport during rush hour is, you can't predict that next word unless you reason through traffic patterns and geography. The LLM is just predicting the next word, but to do it, it has to calculate the entire behavioral path of someone who actually knows their stuff. So the argument isn't wrong, but it's like saying a grandmaster chess player is just moving a piece of wood. Technically, yeah, but to know which piece of wood to move, they had to simulate 1,000 different future realities in their head. But how did the math get so good at predicting words that it accidentally started acting like a brain? To answer that, we have to look at a key technical architectural piece of LLMs called a transformer. You've probably heard this term 1,000 times, but most people treat it like a black box that just magically works. If you actually want to understand how a pile of math starts acting like a brain, you need to go a level deeper. Before transformers, AI read text 1 word at a time. It was super slow and it would forget the beginning of a long sentence, so it would lose context. And to fix this, researchers moved towards parallelism, processing the entire prompt all at once. But there's a catch. When you process everything at once, you lose the word order. To the math, the phrases "dog bites man" and "man bites dog" looks exactly the same. That's kind of a problem. So to solve this, the transformer uses 2 genius tricks: positional encodings and self-attention. Positional encodings assign a number to every word in the sentence, and it tells the model exactly what the sentence order is. When you capture the word order, you're 1 step closer towards capturing context. The real breakthrough with transformers, though, is a concept called self-attention, which gives the model awareness of intent. For example, Server, can I have the check? And I just crashed the server. That one word means two completely different things, and in past AI models, it couldn't tell the difference. Self-attention fixed that, and it's the core engine when we're talking about reasoning. It acts like a spotlight system. For every word the model asks, which other words in this sentence matter to me? In the first sentence, the spotlight for server shines brightest on check. And this is the magic. This creates a context vector, which is a mathematical map of what the word actually means in that specific moment. Think about how often you misread a text because you couldn't tell if someone was being mean or sarcastic. If an AI uses self-attention to perfectly calculate intent from context, is it possible that the math is actually better at reading people than we are? Let me know what you think in the comments. Now, researchers learned that when you stack hundreds of layers of this math on top of each other, you get something called emergence. The model starts to recognize patterns that aren't just about words, but about structure. It realized that to predict the next word and minimize errors, it has to follow the mathematical shape of logic. So by stacking so many of these vectors on top of each other, models learned that in human language, certain concepts always cluster together in a specific logical order, and it accidentally started mimicking the way we think. Now, at this point, the skeptics are going to say, okay, fine, it's a huge statistical model. It's just a massive math equation that's really good at guessing. Technically, they're right, but not for much longer. To see where AI is actually going, you have to look at where the math lives. You have to look at latent space. Oh, by the way, I am in the coolest place ever. If you want to see where I'm at right now in the world, I will link it in the description. Since transformers weren't originally designed to think through problems, there's an architectural limitation of how far we can take them. They hallucinate, they contradict themselves, they get lost. Researchers tried to fix this with chain of thought reasoning, teaching models to think out loud. And it works to a point, but it's not real reasoning. Humans don't narrate every micro-thought in full sentences. It's like you trying to solve a Rubik's Cube while describing every single twist out loud. You're almost guaranteed to get lost. The AI field is realizing that the solution may be to stop forcing models to explain every thought in words, and instead let them reason silently inside their own hidden space where all that computational math lives, which is called latent space. Think of latent space as the model's mental map of the world. An AI model's data is mapped in this multi-dimensional space based on how concepts relate to each other. Take a breath. Lots of fancy words, I know. I'm gonna make this super easy for you so you sound like a pro. Imagine you're in a 3D space in your living room, and every point in the air represents a concept. The idea of cat lives right next to dog because they're both animals, but it's miles away from car. And instead of using words, these concepts are compressed into numbers, mathematical representations of knowledge. Latent space computing lets the model reason directly inside this multidimensional space, instead of translating every thought into human-readable text. It gives the AI a dialogue and whiteboard of where it can try out ideas, simulate results, throw out the bad ones, before it gives an answer. Why this matters is it gives us something that current LLMs can't do: the ability to hold multiple possibilities in mind at once. Today's models lock into one path, word by word. If they mess up early, they're stuck. But latent space models can explore several paths in parallel and only give you the final answer once the math confirms it's the right one. And latent space computing isn't sci-fi because these models already exist. One example is an HRM, but there are many others. This is where the entire industry is heading. But would you actually trust an AI that reasons silently instead of showing you its steps, or would you want to see how it actually came to that answer? Let me know what you think in the comments. So, back to the big question. Do LLMs actually reason? If you mean, do they think like humans do, the answer is a flat no. But we don't even fully understand how the human brain creates logic or connects ideas. What is clear is that we have accidentally discovered a new kind of computational logic. We created a system that found the mathematical shape of our ideas and logic. The more important question to ask isn't whether AI can reason like a human. The real question is, does it need to? If we can build a system that understands the universe through pure math and patterns, we could be building something entirely different. It could process the world in a way we can't even imagine, for better or for worse. But that's a conversation for the next episode. I used one of your comments from the audience to shape this episode. I love answering your questions. I will do it again. Please remember to comment, like, and subscribe. Cheesy YouTube. It means so much to me, and I will see you all next time. Oh, by the way, I am in the coolest place ever. If you want to see where I'm at right now in the world, I will link it in the description.